You are standing on the deck of a ship, somewhere between Miami, Bermuda, and Puerto Rico. The water beneath you stretches flat and calm in every direction. The air is warm. The sky is clear. There is nothing unusual about this moment. At all. And then, without warning, the surface starts to bubble. Not a ripple. Not a wave. Something deeper. Something rising from far below, pushing up through the water column in a slow, deliberate surge. And before you can process what you're seeing, the ship begins to tilt. This is the Bermuda Triangle. And for more than a century, it has been blamed for swallowing ships and planes whole, leaving no wreckage, no debris, no survivors, and no explanation that anyone could agree on. But here is the question nobody in those best-selling 1970s paperbacks ever stopped to ask. What if the real answer isn't supernatural at all? What if science has quietly, methodically, almost completely solved this mystery? And almost nobody noticed? The Bermuda Triangle covers roughly 500,000 square miles of open ocean. A rough triangle drawn between Miami in Florida, the island of Bermuda, and the city of San Juan in Puerto Rico. Over the past century and a half, it has been linked to more than 50 ship disappearances and over 20 aircraft vanishings. Some of those incidents have been explained. Many have not. And out of all of them, one stands so far above the rest in terms of sheer inexplicability that it became the foundation of the entire legend. Flight 19. The 5th of December 1945. It started as a routine afternoon training flight off the coast of Fort Lauderdale, Florida. 5 Avenger torpedo bombers. 14 crew members total. All experienced enough to handle a standard navigation exercise out over the Atlantic and back. The kind of flight these men had done dozens of times before. Conditions were reasonable. Nothing about the briefing that morning suggested anything other than a standard training day. Hours later, something went wrong. Radio transmissions captured a flight leader who sounded increasingly disoriented. He reported that his compass was malfunctioning. He said that nothing around him looked familiar. He couldn't identify the ocean below him, couldn't reconcile what he was seeing with any chart he was carrying. A massive search and rescue operation was launched. Aircraft and ships fanned out across tens of thousands of square miles of ocean in the days that followed, hunting for wreckage, for life rafts, for an oil slick on the water, for anything at all. They found nothing. Not one piece of wreckage from any of the 5 aircraft was ever recovered. Not a single life jacket. Not a single personal item. 6 aircraft in total, including the rescue plane sent to find them, and 14 men. Gone completely. As if the ocean had simply opened up and taken them. Stories like that are the reason this patch of ocean became legend. Bermuda Triangle books sold millions of copies throughout the 1970s, packed with theories about electromagnetic anomalies, portals to other dimensions, time slips that deposit ships and aircraft into other eras, and alien intelligence using the triangle as some kind of collection point for specimens of human technology. That last one appeared in multiple books, with complete seriousness. For decades, that is the version of the story most people grew up hearing. But here is the twist almost nobody expects. The United States Navy does not recognize the Bermuda Triangle as an officially hazardous region. The Coast Guard does not either. The Lloyd's of London insurance market, which has been pricing maritime risk for over 300 years, does not charge higher premiums for ships crossing through the triangle. Statistically, when researchers have gone back and carefully examined the actual records, accidents happen in the Bermuda Triangle at rates consistent with other heavily trafficked shipping and flight corridors anywhere in the world. The mystery was built not on an unusual number of disappearances, but on how the existing disappearances were framed, connected, and told. So if the triangle is not uniquely cursed, if it is not a gateway to another dimension, what is actually happening? This is where the real investigation begins. And it starts not with the supernatural, but with geology. Theory 1 centers on something most people have never heard of: methane hydrates. These are ice-like crystalline formations that develop on the ocean floor in specific conditions, extremely cold temperatures combined with extremely high pressure. Inside these formations, methane gas gets trapped in a kind of frozen molecular cage, held in solid form by the weight of the deep ocean pressing down on it. The continental shelf edges within the Bermuda Triangle, particularly the slopes dropping off into the deep Atlantic, contain significant deposits of exactly this material. That much is confirmed. Geological surveys have documented these deposits. This is not speculation. Here is where the mechanism gets genuinely unsettling. If an underwater landslide occurs, or if ocean temperatures shift enough to destabilize these frozen formations, they can release a massive bubble of methane gas that rises rapidly toward the surface. When that bubble reaches the water column, it does something extraordinary to the physics of the water itself. It reduces the density of the water, significantly, abruptly. And a ship floating on the surface of the ocean is floating because the water is dense enough to support it. The moment that density drops below a critical threshold, the support disappears. Not gradually, instantly. A ship that was floating normally one moment could lose its buoyancy so suddenly that it sinks before anyone on board can send a distress signal, before any debris field can form, before anything visible happens on the surface. At all. The ship simply goes down. The gas continues rising and dispersing, and it leaves nothing behind except open water. Laboratory experiments have actually demonstrated this effect working exactly as predicted. Researchers have sunk-scale model ships in tanks using controlled methane bubble releases. The ships go down fast, and they leave almost nothing behind. The same gas release could also explain the vanishing aircraft. A large methane plume rising through the atmosphere reduces air density in ways that can affect an aircraft's ability to generate lift. Methane is also highly flammable. A spark from an engine, a lightning strike near a large methane cloud, and what you get is not a gradual crash, but an instantaneous explosion. It is a genuinely compelling mechanism. It is also importantly unproven in exactly the way you need it to be proven to call it an explanation. No scientist has ever directly observed a methane hydrate release of this scale occurring in real time in connection with an actual disappearance. The continental shelf deposits are confirmed. The lab experiments are confirmed. But the direct causal link between a specific release and a specific disappearance does not yet exist in the scientific record. This is a theory built on confirmed components that has not yet been assembled into confirmed cause and effect. So what else might explain it? Theory 2 might be the most boring answer in all of maritime mystery. It is also depending on who you ask the most likely. Rogue waves. These are massive, unpredictable walls of water that form when multiple wave systems from different directions converge unexpectedly in open ocean. For most of modern history, ocean scientists seriously doubted these waves were real at all. Sailor reports of 100-foot walls of water appearing out of calm sea were dismissed as exaggeration, as the kind of tall tale that gets taller every time it's told in a harbor bar after enough rum. Naval engineers designed ships based on wave height models that treated anything over 30 feet as a statistical impossibility, a once-in-10,000 years event not worth engineering for. Ships were built accordingly. Then, in 1995, on New Year's Day, an oil platform in the North Sea recorded an 84-foot wave with scientific instruments. Undeniable. Documented. Impossible to dismiss. And once satellite radar became capable of scanning the world's oceans systematically, researchers started finding dozens of similar massive waves around the globe within just a few weeks of observation. The waves sailors had been describing for centuries, the ones that appeared without warning from calm water and destroyed ships before anyone aboard could respond, were real. They were common, and naval science had spent decades building ships that couldn't survive them. Picture being on a vessel in flat, normal water. Nothing unusual on any horizon. And then a wall of water 10 stories tall appears, with almost no warning at all, traveling fast enough that you have perhaps seconds before it hits. A wave like that can capsize a large vessel in those seconds. Far too fast for a distress call. Powerful enough to scatter any debris across such a wide radius that search teams find nothing in the area they search. The Bermuda Triangle sits directly in the path of the Gulf Stream, one of the most powerful ocean currents on Earth. Where a current that fast collides with opposing winds, with the cold Atlantic deep, with the chaotic wave patterns generated by Atlantic storm systems, the conditions for rogue wave formation become significantly more probable than in most stretches of open ocean. This is not a fringe idea. Rogue waves are a well-documented oceanographic phenomenon that happens to occur in a region that already has a reputation problem. Theory 3 gets far less attention than gas bubbles or giant waves, and it might matter more than either of them. It is also the least satisfying if you are hoping for something dramatic. Simple human error, layered on top of genuinely difficult conditions. The Bermuda Triangle is not some remote, rarely traveled stretch of ocean. It is one of the busiest shipping and aviation corridors in the entire world. More vessels and aircraft pass through it in a single year than through most of the planet's ocean regions combined. That volume alone means that mathematically, even at a completely average accident rate, more incidents will occur there than in quieter stretches of ocean. And more incidents means more stories. More stories means more journalists. More journalists means more books. More books means a legend. Add in the actual conditions of the region, sudden tropical weather systems that develop in hours, squalls that appear on clear days, and a Gulf Stream current that changes speed and direction in ways that can disorient even experienced navigators. And what you have is not a mystery zone. It is a difficult environment that punishes mistakes more severely than calmer regions would. Flight 19 itself, the cornerstone case, the 5 bombers and 14 men that launched the entire legend, has a far less mysterious explanation in the official Navy investigation records. The flight leader's compass was malfunctioning. He became disoriented over open water without landmarks. Weather deteriorated during the flight. And then the aircraft ran out of fuel over open ocean at night. No portal. No vortex. No alien interference. A tragedy built from a mechanical failure, a disoriented pilot making wrong decisions under pressure, deteriorating conditions, and fuel that ran out before anyone could find them. So which theory is correct? Honestly, probably some combination of all three, depending on which specific incident you're examining. Some disappearances likely trace to violent, sudden weather that leaves no time for distress signals. Others to navigational error compounded by the region's genuine difficulty. A smaller number potentially to the genuinely strange physics of methane hydrate release. But here is what is almost more interesting than any single theory. What the mystery itself reveals about how we process the unexplained. A region with a modestly elevated number of incidents sitting in one of the world's busiest travel corridors became a global legend not because the statistics were unusual, but because storytellers did what storytellers have always done. They connected unrelated events into a single dramatic narrative. They gave the narrative a name, a shape, a triangle, something that could be drawn on a map and pointed to. And once that narrative existed, every new disappearance got pulled into it. Whether or not the incident actually occurred within the triangle's boundaries, whether or not the details fit, whether or not the disappearance had a perfectly ordinary explanation waiting in the official records. That is not a flaw unique to the Bermuda Triangle. It is how human beings process uncertainty everywhere. We are far more comfortable with a mysterious, unified, meaningful cause than we are with the harder truth. That bad things sometimes happen for ordinary, scattered, unrelated reasons. That the ocean does not require a curse to be dangerous. That experienced pilots and sailors can make fatal mistakes under pressure. The ocean was always dangerous. It does not need a legend to be that. It already is one all on its own. You are standing on the deck of a ship, somewhere between Miami, Bermuda, and Puerto Rico. The water beneath you stretches flat and calm in every direction. And now you understand that the bubbling you saw earlier, the thing that felt like a warning, was not a portal. It was not a sign. It was the ocean, doing what oceans do. The real danger was never a mystery at all. It was just the water, doing exactly what water has always done.